Now we're live from downtown Mill Bay. That's like the old saying. Always shoot for the moon. Because if you miss, you'll be amongst the stars floating forever in endless space until the universe turns to dust, dying the entire time. Because if you do miss in space, you're just going to drift absolutely forever unless you get caught by a gravity well. We don't have that real sense on Earth because everything slows down. But that's because Earth is full of friction. We have air, unfortunately. Now, a change, what does that symbol mean? Yeah. It is a delta? What is it? I don't know if you've seen this in math or previous physics. What does it mean in formulas?
If you have like delta x, it's like change in x.
Change in x. So it means change. So if I have delta t, that would equal the final t minus the initial t. It doesn't matter. It's just the change. It doesn't matter what that symbol is. It just means change. That's a capital delta. That is also a delta. And you probably won't see it, but it means a little change, often one smaller than one, and one we don't want to write down the number for because we're lazy. Capital delta means a change. So I have a change in distance. What do we call a change in distance? Yes? Kind of, but in physics. We measure a change in distance in a certain way, and we have a whole separate word for it. No, thank you. But thank you for offering. What do you think it is? Well, you put up your hand. Yeah, velocity. So velocity is a change in distance. Once you put something over time, it becomes a change in. So a change in distance, and we will put over a change in time, is equal to velocity. And we needed that concept to say that a change in velocity is, what is it now? I walked at constant speed, but if I was to like demonstrate acceleration, I'd have to start slow and then gradually get faster and faster and faster and faster as I was knocking over desks, which I'm not going to do. But then I can just slow down because that's also a change in, what is it when you change the velocity? Acceleration. Deceleration and acceleration are the same thing. Both of those are acceleration. The English language is like the word for the slowing down one. Someone else who hasn't answered a question. Units of acceleration from last day in gravity. Anders? You don't appear to be writing the notes down. Have your notes out properly. Pen to paper. Yep. Looking at the board, writing the things down.
I did write the things.
You glazed over way too much. Eyes were heavy. So, next question. What are the units of acceleration? From gravity, last day. You what?
Last class.
Last class, yes.
We left early.
We left early.
How dare you? How dare you? Okay, I'll give you the notes.
It was the 9.
They are the units of gravity, because gravity is acceleration. So, Anders, on the board, find gravity. What are its units?
9.80 meters.
Yeah, which one of those is the units?
Meters.
Part of it, meters per
Second.
second squared. So, the ones at the end are the units. These are the ones that tells you what kind of thing it is. Yeah.
How do you write acceleration as like you're going at 1 kilometer an hour, now you're going at 2 kilometers an hour? How do you write that with acceleration?
To calculate anything that is a change, so we look what we did for velocity. What would we do for acceleration?
One subtract the other.
Pardon?
First one subtract the second one.
Yeah. So this is change in distance over time for velocity. And what would be the formula then in the same kind of way for acceleration? What are we changing over time? Speed. So our, not speed, velocity. Change, I mean, at this level it doesn't always matter. But what is the difference between velocity and speed, Jay?
Velocity is direction and speed is
Have you seen the movie?
Speed.
You know Keanu Reeves?
Pardon?
You know Keanu Reeves?
No. The one with hold it.
Second one after Palmer. Okay.
No, the guy who made the moon disappear. Gru, Minion, not the first one. Despicable Me. What was the name of the bad guy? Vector. With both direction and magnitude. Direction matters when you get on later on in physics, because later on in physics, it's not just you're right now. We're introducing this. You're going to be doing things in one direction. It needs to be a song now. But you could have a force that's pulling on something this way and that way, and now you have to take into account the direction in which way it's actually going to go. So velocity includes direction. Most of our examples are going to have it only going in a single direction, so it will be synonymous with speed, but it has direction. So to calculate acceleration, the change in velocity over the change in time. So your example, it was going 1, and then a second later it was going 2. That would be change in velocity is 2 minus 1 over 1 minus 0 a second later. And so we have acceleration of 1, whatever your units are, meters per second, probably.
What's that like a curved line next to the?
A comma.
Okay.
Yeah.
Okay.
Now I'm going to see if here. Come, today's first demo. It's amazing.
Just give me an EV center.
gone?
It worked.
Well, it didn't get all the way to the end, but it went around the loop de loop. Someone's eyes were affecting you. So this is where you learn that magic exists. And someone has the evil eye. And I don't know who.
Why don't you just look up a video of the roller coaster online?
That one was fun.
Yeah, that's not fun. What are you talking about?
You should do the.
That's just crazy stuff.
Isn't there one with like big bowl?
Zach, we're doing.
Oh. Speaking of, hold up, what time is it? We're gonna do this. There is a video I want to show. Gravity. However, first, let's make a car. Hold it. Those didn't move. Are they separate? Oh, they're mine. Okay. Examples are roller coaster. We saw that moving. When it's climbing up, so it's zooming up. It approaches, so it comes here, it goes, and then it continues down the hill. They're just at different angles. And then when it comes to the bottom of the hill, it has to go up. So when it's going up, what is happening to its acceleration? Slows down. What was the problem up there with the loop-de-loop?
They didn't have the.
Yeah, it didn't seem to quite get around it. It was like I went and tried it this morning and it went boom, 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 and hit right to the end. Cool. Did it again. Boom, boom, boom. Went right to, I didn't set it up. One of the physics teachers did. They're really good at it. I usually get it wrong. And then I take you out, and then it goes, what crash? Gravity is clearly increasing on planet Earth, and we're all going to die. Yes.
What does that say?
What? Oh, that word? Decreases. I will only recognize the part that you couldn't read. Decreases. When it's going down, what is it doing with its acceleration? Pardon? Increases. And when it coasts, so at the very, very end, it's just going. What's happening to its velocity?
Slows down.
Why?
There's nothing else pushing it anymore.
Right. Why would it slow down?
The air resistance.
Are we using air resistance?
All I know is when I go on a roller coaster, when it like flatlines, it stops.
It does. Imagine there was no friction. You're in. This is a roller coaster in space.
And it keeps going.
Keeps going.
Same speed.
What happens to its velocity?
Stays the same.
Stays the same. Yeah.
If we were in space, there'd be no acceleration going downhill,
Shh.
or it would jump straight
Hold
to
it.
the track.
Yes, it would. Because we're on a planet without an atmosphere. In space.
Red Swiss cheese.
I still think that's wrong, but it works for now. So, when it coasts, its velocity is constant. And what's its acceleration if its velocity is constant? Yes?
1,
Nope.
0.
0. Acceleration is 0 meters per second squared. Because at any moment of time, it's not increasing or decreasing its speed. If you were to calculate it, the velocity is 20 meters per second, and then a second later, it's 20 meters per second. 20 minus 20 is 0. Anything divided by 0 is 0. Decreases. Acceleration is, what's the acceleration? If the velocity is decreasing. You don't have to give the exact number. You've answered a lot. How did you feel? Haven't?
I think so. It's gravity.
Oh. This is a big phone. If your velocity is decreasing, is your acceleration positive or negative?
Negative.
It did. Negative. And if the velocity is increasing, is it positive or negative? Positive. So positive acceleration is getting faster and faster. Getting slower and slower is a negative acceleration. I feel like we should fill this up. Let's do it here. Let's put them back there, so it's the same as your notes. And we'll put that here. 1, 1. Yep.
Do we just like assume it's in space then?
You can assume for all of these that you're not going to consider friction.
Okay.
One of the realizations and how we were able to figure out physics and all these formulas is when you are doing things on Earth, a lot of things become really complicated. And you have to account for things like friction and air resistance. But the actual formulas themselves are very simple. And if you remove those things, they're a bit easier to understand. So we teach it without friction first. And once you're good at it, later on we throw in all the complicated stuff. Isaac Newton, in his version of physics, all the laws assume things like friction don't occur because you just add them in if they do. They're just another force. Velocity increases, acceleration positive. Why do I can't view, zoom, entire page? Such a big page. And then 3. It's coasting. Velocity. 0 meters per second. Nope, that's not true. Velocity is equal to a constant. Acceleration is equal to 0 meters per second squared. A is equal to delta V over delta T, which is equal to V minus V. Yeah, coast. You're coasting. At some point. T final, what's it? T inertia. Good. Excellent. What? Good. Anybody not good? What are you not good about? No. Any other complaint? Generally, school, life, existential crises. Yeah.
You know a car can accelerate like 40 kilometers an hour in a second, right?
Pardon?
The next page.
Oh, we're not on the next page. Did you know that if you add up all the numbers between all the whole integers that are positive, you get infinity. But if you add up all of the real numbers between 0 and 1, you get infinity, and they're the same size? of infinities.
Okay.
Yeah, it really bothers me.
Okay. You got that.
Pardon?
You got that.
Well, no, if you take 1 and you add 2, you get 3, plus 3, you get 5, no, 6, and then you keep adding them on. You get infinity if you keep doing that forever. But if you take 0.1 and add 0.2 and add 0.3, but then you get to 0.9, but then you can go back and go 0.11 plus 0.21, and then you can go back and go 0.111, and you can do that forever. And if you add all those numbers up, it is the same size as the infinity of adding all the numbers. And then this third one really bothers me. If you add up all the real numbers, including the positive whole numbers and the numbers in between, you get infinity, and it's also the same size. No, that's not an account, but this is deeply wrong, and I would like to correct the mathematicians who came up with it, because I find it disturbing. It should not happen. But then again, they're the ones who invented naive theory, so. Next page, I would like you to set this up with a calculation. Mr. Neufeld is traveling at 14 meters per second and saw the fuzz. 2.0 seconds later, he was traveling at 56 meters per second. What was his acceleration? Moon stopped and asked why he was going so fast. Mr. Neufeld said, lawyer said not to answer any questions. Here's my driver's license and registration. Never talk to the cops. What are you doing, man? It's gonna throw you in the clinker. Or yesterday, I was going to get pizza for a few boys. Left, turned right, not you. And I got a ticket on my way to Moose because I was going 200 kilometers an hour. But I got out of the ticket. I said, officer, I couldn't possibly be going 200 kilometers an hour. I've only been driving for 2 minutes. That wouldn't be workable. 200 kilometers an hour? Okay. Do the problem. And I want to see how you set it up. So, fastest way to do that. This is block C. Block C. Block C? Toolkit? No, yeah, toolkit. Oh, who's attendance? Anders,
He's here.
Caden, Darren, Esther, Hillary, Jennifer, Jojo, Julian C, Julian G, Liam, Lucas, Mirhat, Nick, Oliver, we're all here. Today's red letter day. Let's do it in groups of 2. Find a spot on the board, show me your setup.
Perfect.
Do not erase. You can't erase this. I think that was, erase that. You can't erase that. So, going up, grab a marker with your partner and show me how you're going to set it up. Write the formula first, then put in the numbers with units. And then I'm going to go along quickly and mark it. You can use the glass over there if we're running out of room. Who's your partner? Oh, excellent. Anybody else? Go use the glass. Grab some pens and just use the glass right there. You got lots of room there.
Is it this one minus this one?
All right, no units, no formula. You need the units and the formula.
I know the formula is just this.
No, the formula has no numbers in it. Write down the formula and then the calculation with all your numbers. Excellent. No, you have to use it.
I still got the right answer, so.
Yeah, we double check.
Right answer doesn't matter. You can actually get the wrong answer. As long as you do the right numbers and formula, you have pretty much extended it.
On second thought, I used the formula.
Yeah. But if you don't use the formula, you have proficient at best.
Oh, yeah, I've heard of it.
I
Nicely done.
This is the same.
Wait, I need a marker. Can
Um,
I get a marker?
You do need units, and I think you have the wrong formula.
This is the
Oh, you never want that. That's okay. You can drop acid.
New foot,
You never drop base. Pardon? In that big pile over there. Once you're done, have a seat. I will go along with it. I'll leave it. Mm.
Wait, Mr. Email?
Mm-hmm.
What the formula? Is it like so?
What do you mean what it's for?
No, I mean like.
It's right here.
Oh, but
It's right here. It's right
I just
there.
How do I like? I don't know how to say it. Never mind.
What?
Because like it's changing velocity by changing time, but
Yeah.
changing time would be 0 minus 2.
Oh.
Or would it be?
No, because it's final minus the initial. So it's your final time, which if you start at 0, then yeah, so you start at 0 time.
Okay, I think where does it?
I did it there.
Oh, you trying to get a shot?
Sure. Of what? No, not that kind of shot. No, walk up, put it in, stop throwing things in the
Bang
water.
it in though.
No. Regatta's looking for more volunteers who need more work.
I already have it.
I know. They're assigning people to multiple jobs.
Yeah, I'm annoyed. I have two.
House parents are allowed to put in any.
Problem with the
Zach, just Zach, leave it.
another email saying you're doing live.
Yeah, they changed it.
What are you doing?
Oh, no, that first one.
Wait, how do you do the?
And we're racing.
Please do not write all over the board. That's
I'm
not
not.
what I do.
Oh,
What are you doing?
it's just negative.
No, don't touch it. Don't touch it. Have a seat,
What's
please.
negative? Oh yeah, who's Don Elder?
I'm going to go Control Z. There we go. I don't know what you're talking about.
I see.
I still don't know what you're talking about. No, I think it's really first half also. Okay. I'm just going to go on now. At this level, I know I encounter a lot of students who go, I got the right answer, therefore I'm right. The right answer is an emerging level of proficiency. The correct answer has the formula, the data for the formula, the units for every single number you write down, and then showing the calculation, and then the right answer. If you have all of the other things, but you misplaced your thumb on the calculator and you just press the wrong button, and you get the wrong answer, but everything else is right, that's still like, depending on the question, extending or proficient high, one of the two. If you only have the right answer, that's emerging, because it's not about getting the right answer. The math isn't that hard. It's about understanding the question and communicating what this is. And the units really communicate what it is. The formula tells the person what you're doing. And so, I'm calculating acceleration. So, delta V over delta T, that's not bad. And then they put this in. They have the wrong units. And they calculated, so here, you minus meters. So technically, this should be in meters per second by your calculations. So you need to have the correct units. The units for this particular question are meters per second and those are meters over 2 seconds, so it's not quite the same thing. This one looks pretty good. We've got the formula, we've got all of the numbers, we have the final answer, which I'm assuming is correct, and we've got the correct final one here. It may be nice to expand that out as a formula, but that would be sort of a quibble. This one, I do not know what you're calculating. This just has units. This needs an acceleration, so you need the formula. In there, ooh, I like this. They have the formula, but then they expanded it out. I don't know what P stands for.
Page, file.
No, but it may be that my writing was so messy, someone thought it was a P and then just copied it. It is V final minus V initial, T final minus T initial. So no P's, that may be my fault. Unfortunately here, sadly,
What is this question?
no units.
Soft fuzz.
Going so well, and then sadly, they lost their units and they became rudderless, adrift in an ocean of formula. Yep,
Have you seen the video, the example one of the guy jumping from space?
yep.
So he is like, he went the fastest out of anyone, any human in it.
I don't know if he did, but
Oh, no,
I think he went the highest.
Yeah, he jumped
Yeah.
up. But I thought like, you can go like faster than a certain.
You can't because of air resistance. We're ignoring that. So if he did that over, say, the moon, from far enough away, he might be able to go even faster because there'd be the moon actually does have a very slight atmosphere, not very much one. You can pretty much ignore it. You might, even though the moon's gravity is less, he might be able to get up enough speed. Also, if you have the Earth and the moon, there is a spot in between them where the Earth's gravity and the moon's gravity cancel out, and you can just float there.
Wait, is the Earth is the line, right?
Yeah. Obviously.
Because it's flat.
Yeah. Yeah. I mean, I'll draw it face on. Then it looks like that. Good. This one, delta V over delta T, beautiful, no units. Sad. Units in the final answer. They came back. Nice. You know what you're doing? When I showed you kilogram meter squared per second squared, the reason for that is if you're keeping your units all the way through, you can verify if you got the right answer or not. You know you're doing energy, and you carefully multiply your units out, and you get kilogram meters per second squared, you can know, oh, I need to go find a distance somewhere. I forgot something. Your units will save your butt. And I stopped memorizing formulas once I learned how to do unit in university. This is a capital A, and this is where I'm going to get really picky because you don't even know this yet. But capital A actually means amperes, and it's a unit for current, and so it's not acceleration. You have to use lowercase. In the same way that if you have a small m, it means mass, or it means milli. If you put it in front of another m, then you have millimeters. Big M means mega. So we actually, it makes a difference between uppercase and lowercase in physics because all of the letters have been assigned. So don't capitalize if you don't have to. I mean, I didn't tell you that, so that. But no formula and no units. Or formula. 14 minus 56. Ooh. This you're so clever. You actually, this is where two wrongs actually made a right. Because it's the final velocity minus the initial velocity. And they did the initial minus the final. But they did it twice and got two negative numbers. A negative number divided by a negative number is a positive number. And that still works. And there's technically nothing wrong with it. Because according to all the laws of physics, However, need a units. And we do.
On a test, if we do it the wrong way around, but it still gets the correct answer.
Finals minus initial, part of the reason we teach it, I teach it that way, and everybody does, is so that you're always consistent. You don't want to do finals minus initial and then initial minus final, because then you'll get the wrong side. But if negative, and we also teach it that way because you always get positive numbers, so that it's less likely that someone's going to make a mistake and keep you negative. But you can do it the other way, as long as you're consistent.
What's the fuzz?
The police, the popo,
The
the cops.
The ops. The boys in blue. We've got ops.
Is the fuzz your ops?
The fuzz? What?
Fuzz. The fuzz.
Yeah, I know. What is it?
Are they your ops?
My ops?
Yeah.
Opposition. Opposition. Your enemies.
Your opponents.
No.
You run the no way ends.
Mm,
That's me.
Road man. Remember that? Road man. He's kind of a bad man. Really bad man. I think it's from the garden.
sorry, I was just going to grab a question from your sheet, but my phone doesn't have it. So, home page. I need another example. How fast was I traveling?
27
And let's change this.
kilometers.
And I didn't see the fuzz. I saw
The ops.
a small cat.
Child.
The ops.
Child.
Oh, CTC breaking.
Yes.
He was traveling at 2 meters.
The traveling juvenile. 32 seconds after he left Brentwood and saw a small child. 97 seconds after he left Brentwood. He was traveling at,
2 meters a second.
pardon?
2 meters a second.
Excellent. I slowed down and I'm trying to save the child. Really worried there for a moment. The child lives. What was his acceleration? I'm going to write the old one. I'm going to put down everything. What I would like you to do is go up with, let's give you a different partner. Oh, where is it? And if there's any criticisms and things I want you to improve, I just want you to get used to doing it right. Find your new people. Go up. Get her down.
Wait, so
Oliver, can you toss me a marker?
I don't want to go. You have to identify that.
Who's your partner there, Julian? Who's your partner?
Yeah.
Vienna.
Wait, should we do it on the paper or on the board?
Do it on the board. Do it on there. I'm going to do the old one. Oh, I just realized you can't see this. I'm going to keep this here then. So you do this one. I'm going to write on here the solution to the other one. So ignore that. Man, that's huge. I don't want a shape recognition pen. I just want a pen.
97 minus
97 seconds.
What am I doing? This is the old one I'm doing, so ignore it. What was I doing initially? 14. You're doing this one. I'm doing the previous one just so that there's a record for anybody who needs to review.
I don't know what you guys about this.
The chat will be 1,000. Just like sleep. No, it's like final minus that's initial. Yeah.
Negative.
So the previous problem is on the board.
Do we have to convert between seconds and hours?
I didn't ask you to convert to meters per second. So you can keep it. This is the previous problem.
Yeah, but that's currently the act.
What?
The wording at the top though still has kilometers and seconds. We have to convert.
Oh! I just realized it makes it a much more complex problem because I still use seconds without thinking of it. You would have to convert either the seconds into hours, or I would have to change numbers to make it easier. I think you can do that. That's not hard. How many seconds are in a minute? 60. So I'm going to, everybody's got their groups. I'm going to get rid of this. Because one of the most useful things that you will find when you're doing physics is time is always given in minutes, seconds, hours, years, and you always have to convert it into the same one. So you know the relationship that there is 60 minutes equals 1 hour, and there is 60 seconds in 1 minute, and these are any fraction you want. I just have to check one thing about math. If I have A times B times C divided by B, what does that equal? Does there, you know that you cancel B, right?
Yeah.
Right, okay. As long as you know that, I'm not doing anything advanced. Here's what you do. You have these relationships, and if you're very clever, you remember that 3,600 seconds is in 1 hour, and you do it in one step. But you say, I want seconds. Let's give myself some times. You want seconds, but you're starting off with 32 seconds. You have 32 seconds, sorry, and you want hours. So you need to get hours on top. Currently you have seconds on top. You know there's 1 minute is equal to 60 seconds. So you can multiply that, and every relationship that exists is a fraction, and you can put it either way. So you can say, oh, I'm going to multiply that by 1 minute over 60 seconds. What happens to our unit of seconds? Disappears. Now we have it in minutes. If we take 32 divided by 60, you get 30 divided by 60 is roughly a half. That makes sense because 32 seconds is about half a minute. Now, but we still don't want minutes. We want hours. What would we multiply by to get hours on top? And 60. We would go, someone says 60 minutes. We put 60 minutes on top?
1 hour.
We put 1 hour. We want minutes to cancel. If we have minute over times minute, what do we get? Minute squared. That's a weird unit. I mean, you could use it for, so take that, put it down, and now finish the relationship. There's 60 minutes in 1 hour, and then you go, oh, minutes cancel. And if I go 32 divided by 60, take that number, divide it by 60, I will get the number of hours. Show that as two separate calculations for your 2 seconds. You'll get a decimal for hours. I'm actually really I did that on purpose to show you this. Yeah, it's going to be small. It's tiny. But it makes sense. It's a small part of an hour.
Can we look at the question?
Yeah, I'll put the question back. Show those two calculations somewhere. You just did a much more advanced version. Extremely well done.
What do we round to?
Make sure you have at least two numbers. So 0.000 and then at least two numbers.
Oh,
Okay?
okay.
It's called a bullet coffee. I put in 30 grams of butter,
Okay.
2 tablespoons of whipping cream, artificial sweetener, so there's no sugar, about 2 ounces, and it tastes like a milkshake. So amazing. It's a mocha sweetener today, but I had like vanilla.
It's like the French vanilla.
Have you guys done the question?
So like the times one itself.
Remember to include all your numbers. And while you're working,
He's not doing 32 times 32, he's doing 32 times 1.
There's 60 there.
Yeah, but the 16, no, the 60 is fine. I'm saying the 32 above the 60. This shouldn't just be 1.
They're the same.
I guess so. You continue.
Okay.
Right. Oh, sorry. Yeah.
So we start off with 30 and then you divide by 6. Basically, you just divide by 6. This all the stuff is just to show the circuit.
All 6.
I think you divide it by the and you don't have it now.
okay, gentlemen, you're standing around chatting. You should either be in your group or you're done and you're both your group sitting down. No, I overheard somewhere that wasn't it. But Pablo, I appreciate the hustle. But go with the group. You're gonna get a quiz on it. Nope, I didn't need that. Yeah, right after everybody's done this. So go.
We can try. We don't know.
Oops, sorry. Hold it. No, let you go. Yes?
This is quite difficult. The physics.
This one is more difficult. If you want to pretend those seconds are hours and just do the problem without having to do the conversion, I'll let you do that. Because I made it more difficult. Well, without the conversion? No. No, because I was going 27, and you have kilometers, not kilometers per hour, and you have it final minus this. That's initial. That's right, and then you have 97.
Yes, I just.
97 is the initial, and then you have the final. Yeah, that's good. Other than your units for the top one or all.
You have to write per hour.
Yeah, because
Final.
It's the final time. So final.
you could actually
No, you should see that same thing.
keep the units as they are
Can you just do the usual
and multiply them in.
minus
Do that. like go 2 minus 27 over 97 minus 32, get a number, and put the units in with all of those units, kilometers per hour and second. If you're having trouble with that, I'll help you. Okay? Who's your partner? Julian? That is, I hadn't thought of looking at that, this will actually be really neat. Because you can keep those units, and as long as you keep your units, you have a weird type of acceleration, but one is actually pretty because you didn't do it. So, Julian, where's your calculator? You should be helping calculate. Go. Chop. You do the top, you do the bottom, and then you take the top and divide it by the bottom. Yeah, so it's 2 minus 97 over 97 minus 32. Once you've got it, you can have a seat. You're slaying all day.
So you mean it's maximum?
Got the problem.
So you're right.
Calder, how'd you find it?
Oh, you give me this one.
How'd you
I
find
thought
it?
it was okay,
Did
sorry.
you get a positive or negative number? Good.
I'm motivated.
Because if someone's slowing down, you should get it. Did you do the conversions or did you just get it?
Yeah, I think so.
1 minute.
Corresponding.
It's a negative, whatever the heck that is.
Yeah, it's not meters per second squared. Just come out here. Julian, come here. Because if you take the numbers away, you have kilometers per hour divided by seconds. Right? So you have kilometers per hour seconds. When you go divided by, that just ends up at the bottom.
Yeah, okay, we've gone where we need to
Do you want a singular answer?
If you have, there's always the problem is I don't know how much math you've done. If you have A over B and you divide by C, you get A, B, C. Does that make sense? Or another way of saying that view, A over B is the same as times 1 over C. Those two things are the same. Does that make sense? Okay, so what I'm saying is so this would equal A over BC, right? And this is the same as that, so you get the same. So if you have kilometers per hour times 1 over seconds, because seconds are on the bottom, then you get kilometers per hour per second. You have a kilometer per hour a second.
Is it per hour or per second?
It's both. Remember when we did like meters per second squared? That is meters per second per second. This is kilometers per hour per second.
Is that like common or
It's not common, but in this instance, it's probably fairly useful because we're used to talking about the speed of cars in kilometers per hour. And then this gives you how much faster it's accelerating or deaccelerating every second, which is useful information. So whatever that number is, that's actually useful. You can probably visualize that. That's how fast it's slowed down. Yeah, write it. Okay, have a seat. It's not loud enough that I don't think everybody's working. Come up. Julian, Heather, have a seat.
Yeah, that's true.
Oh, why do you need grads and degrees? Oh my God, what are you doing?
We didn't do this on this.
They made this right.
Yeah, so kilometers over hour, and then 100 kilometers over second.
No idea.
So kilometers per hour. Yeah.
I can measure stuff.
Oh, did you calculate? Like with your math class, like when you do do it by converting the hours into seconds, converting the seconds into hours, which will give us a new unit. Acceleration was meter per second squared, but this is a kilometers per hour squared, which is still an acceleration of the acceleration. It just has different units, which is why your units are important. But also, if you kept it in seconds, you get an interesting result and probably a really visual result, because you can get a kilometers per hour second, which would be before when we said meters per second, and that's every second how much faster it was going. You can probably visualize if we had a negative number, it's deaccelerating. The kilometers per hour, it's slowing down, per second, which is probably also a very useful number. And you can mix and match your units like that, and it's technically not wrong. If I haven't told you what units to do, as long as your units are correct, I cannot argue with you, because you showed your units, you showed your calculation, and you kept canceling them and using them. That's useful. There are times when you're going to want everything to be in meters per second, because you're going to use it for acceleration, and gravity is 9.80 meters per second. So if you're using anything with a constant, you have to get all the units the same. But under specialized circumstances like this one, that's probably a really interesting result. However, I made you do math. Really sorry. You probably need a break. It's 9. Hold it. Do we end at 9:35?
Yeah. I think we still need a break.
I meant to stop you at 9. I saw it was 9:07. I thought, oh, we do one more problem. So you can't leave, because teachers will get mad if I do that. But if you want to just sit or go to the bathroom or grab your phones, I'm going to give you your 5-minute break at the end.